Hello everyone, welcome back to chemistry class. Today we are going to discuss very important topic, that is behavior of ideal gases. Before this we have already discussed KMT, means kinetic molecular theory of gases, but that KMT is totally based on ideal gases, and here we will discuss how do real gases behave. So let us see our topic. So what we have discussed here, that behavior of real gases. Okay. So ideal gas equation PV equal nRT. Ideal gas follow this equation at all temperature and pressure. At all temperature and pressure. Okay. When we try to test this, are the real gases follow this ideal gas equation? When we try to get it, then difficulty arises. When we draw graph, then also some difficulty arises. Let us see here. Difficulty arises when we try to test the how far the relation PV equal nRT. How far the relation PV equal nRT produce actual gas for PV graph and temperature, P, B and means pressure, volume and temperature. A relationship for gases. It means if we draw the graph for ideal gas, they follow the ideal gas equation or gases law at all temperature and pressure. When we draw the graph, when we try to test, are the gases, means ideal gases follow this. So to test this, we try to test it. What? How we can test? Means by drawing graph. We will check, are the real gases follow this, and how long they follow this concept. How long they follow this concept? It means how much distance and how much long they will hold this property. Let us see here. When we try to draw the graph, we try to test. So what first is that we will draw graph, PV graph means pressure, volume and temperature graph. We have already discussed that if we have drawn the graph for ideal gases, there was a straight line graph. To test this, or the real gases follow this, so we are trying to draw graph. Let us see here. What is difficulty arises when we try to test how far the relation PV equal nRT produce actual for PV means pressure, volume, temperature. A relationship for gases means how much long, how much hold this property the real gases. Okay, and here ideal gas hold this equation. PV equal nRT. Means just we have talked here that if we are trying to know the behavior of real gases, to check it we have to draw different graph. So when we draw different graphs, difficulty arises when we are drawing different graphs. Pressure volume graph at constant temperature and pressure volume graph at constant pressure, so we get different variances. That is not like the ideal gases. That is meaning here. Ideal gases, I hold this equation PV equal nRT. Okay, ideal gases hold this equation PV equal nRT. When the graph is drawn between, just see, when graph is drawn between PV versus P, means according to Boyle's law, just see, according to Boyle's law, PV equal constant. PV equal constant. It means when we will draw graph between PV versus P, there will be a straight line graph. There will be a straight line graph for ideal gases. So to check this, we have drawn graph for ideal gases as well as for real gases. Are the real gases hold this concept? Means PV will be always constant. Means according to this concept, according to Boyle's concept, if we will draw the graph between PV versus air pressure, so there will be a straight line graph. Means there will be constant. Means PV is never going to be changed here. So let us see what is when graph is drawn between PV versus P at constant temperature. For ideal gases, so see, for ideal gases, we get a straight line graph along x-axis. We can say along x-axis. Along, we can write along x-axis. Okay. At all pressure. At all pressure means, just sort of see here, I have drawn graph PV versus P. PV versus P graph I have drawn here. Okay. So for ideal gas, what is there? Just sort of see, for if we are drawing this graph for ideal gases.
Excuse me, sir, an unknown is calling you.